Hi, so this is a quick video to go through how to solve DC circuits, how to do calculations with DC circuits involving series and parallel resistors using three rules that we've sort of been over before, but I'll go through them again. So first of all, I'll go through the main concept. So first of all, Kirchoff's voltage rule. So this is in a circuit where we've got a supply voltage, so I'll label that Vs, and we've got two resistors in this case. It could be light bulbs, could be anything else, and they will have voltages V1 and V2. I'll label them, okay? Now, in a circuit like this one, a series circuit, we're going to have the case that the total voltage, the supply voltage, will be shared out between those other two. So we could write it as Vs equals V1 plus V2 for things in series, okay? In parallel, however, if we had the same thing, so we've got our supply voltage and we've got V1 and V2, but in this case, in this circuit, in the series circuit, there's only one loop, okay? So in series, there's only one loop. There's only one path for current to flow around that circuit. In parallel, though, there are multiple loops. Okay, so in this case, we've got a loop that goes around here. We've got another loop that goes around the outside. There's a third loop at the bottom, but we won't worry about that one. Okay, so if we look at this top loop, okay, we'll call this loop 1. In loop 1, there's only two things. There's a power supply and there's V1, so in that one, Vs has to equal V1 in loop 1. In this outside loop, I'll call that loop 2, we've got Vs and we've got V2. There's only two things in that one, so in the bottom loop, or the outside loop, Vs equals V2. So in this one, we can say that Vs equals V1 equals V2. They're all the same, okay? But that's because there's only two things in each loop. So in general, though, Kirchoff's voltage rule can be stated that around any loop in a circuit, the voltage that is supplied equals the voltage that is used. So energy has to be conserved, okay? Now, if we go to Kirchoff's current rule, now, in current, I'll change color here. Go blue, I think. So current flowing, remember, current flows out of the positive in this way. Now, in a series circuit, there's only one path for the current to flow, okay? So the same current has to go, it must be going everywhere, okay? Because there's no other paths for the current to flow. There's no like other, if you think of like traffic, there's no other roads that the traffic could go to branch off onto, okay? So this current is the same everywhere, okay, in a simple series circuit. In a parallel circuit, if we have current here, I'll call this I1, this one, coming down here, I1, and we get to this point here. This is what we call a junction, okay? Now at this point, the current will split. Some will go this way, and some will go this way. We'll call it I2 and I3. Okay. Now, how much goes each way depends on what things are connected in each one, okay? So at this junction here, we can say that all the current that's going in, I1, is splitting up into I2 and I3, but the total has to be the same, okay? Now, on the other side, over here at this junction, we've got I2 and I3 coming into that junction, and we'll have another current coming out, and this one must actually be the same as I1, okay? And that will again be I2 plus I3, okay? So here, so the current is shared between the branches. Now, the way you can say that in a general sense is that at any junction in a circuit, the total current going in equals the total current going out. Those are charges being conserved. So that's Kirchoff's current rule. Okay. Now, the third thing is really a definition. And this is what we call Ohm's law. So if we had a circuit like this, so we've got a, just change color again. So we've got a variable voltage supply, and we connect it to a resistor, we'll call that, and we measure the current and the voltage, okay? And if you were to plot voltage against current, voltage on the y-axis, current on the x-axis, you would get a plot that looks like this, okay? Now, there are cases when it doesn't look like that. We'll talk about those later, but for now, we're just going to talk about that case. So for this case, we could calculate the gradient of that line. So the gradient would be rise over run, which would be voltage over current, and if it looks like this, that's going to be a constant, okay? So voltage over current is some constant. That constant we call resistance, okay? So resistance is just the name for the gradient of that line, okay? So if we know the gradient of that line and we know the current, we can find out what the voltage is. We know that for a particular component, it needs so many volts for each amp, okay? And that's what resistance is. Resistance is just defined as this ratio of voltage over current. That's what resistance is, okay? Now, this equation, I actually kind of prefer it this way. It's like, V over I, but it's normally written a different way. It's normally written like this, V equals IR, which is just the same thing rearranged. I prefer this other one because it's really what it is. It's the definition for resistance, okay? So this is voltage, V equals current in amps multiplied by the resistance. Resistance is measured in a unit called ohms. It's actually, an ohm is a volt per amp if we just do our usual thing of smush it together and name it after a dead guy, okay? And it's got the symbol capital omega, okay? Sorry, the unit. Resistance is capital R, okay? So those are the three fundamental things. Kirchoff's voltage rule, Kirchoff's current rule, and Ohm's law. Those are the three things we're going to be using for solving these circuits. Now, if we look at some simple series and parallel resistor networks, so if we just take this situation, we've got two resistors, it could be 3 or 4, however many, in series. Now, I'm not going to go through the derivation of this, but basically all we would have to do is basically apply Kirchoff's rules and Ohm's law. I might go through this later when I'm back in class, but for now, just take my word for it. If you've got a series network, the total resistance, you just add up all the resistors, R1 plus R2 plus R3 or 4, however many there are, okay? You just add up. So that's finding total resistance. If it's in parallel, it's basically the same, except it's 1 over all those things. So 1 over the total resistance is 1 over R1 plus 1 over R2, and however many there are, okay? Now that's kind of important because you're going to need to use those when it comes to solving circuits. The first step you always have to do, really, is calculate the total resistance of a circuit, or one of the most common steps anyway. Now, if you've got a circuit that is not just series or parallel, like this one, for example, this is not simple. It's like a combination of series and parallel. You've got R1 and R2 in series, but R3 is in parallel. So how would you find the total resistance with that? Okay. Well, what you would have to do is step 1. You've got to look for which part is simplest. Now, at this part, R1 and R2 are just in series. Okay. So the first thing I'd do would be that bit, okay? Step 1, R1 plus R2, because they are just in series. And then the next step would be, change color, I would combine those with R3. So I'd go have 1 over R1 plus R2 plus 1 over R3, and that would be 1 over the total resistance. Okay, so you've got to like do it in steps. Okay, what about this circuit? Again, 3 resistors, but put together in a different way. So again, you would start off with whichever is the first, is the most fundamental part. Now, this part here, R1 and R2, are in parallel. Okay, so I'll do that first. Okay, I'll do 1 over R, I'll call it RP for the parallel part, is 1 over R1 plus 1 over R2. Okay, so that would be, I would calculate that first, so the resistance of that parallel section, and then I would add in the third bit, so we'd then go do this bit. So secondly, the total resistance is going to be whatever that first one is, so it's going to be 1 over R1 plus 1 over R2, so whatever we figured out from that parallel section, plus R3, which is in series with it. Okay, so you can just calculate it up in steps, and those are, you can do that for like lots and lots of resistors, but it probably wouldn't be much more complex than that. Okay, so those are the 2 most common cases you get. So we'll go through some examples. Let's take this circuit. So essentially, solving a circuit, what that means is find all voltages and currents, all V's and I's. So what's the voltage and current for each resistor in the circuit? Okay. Now there are several steps that you usually go through. The first 2 steps are always the same. I'll write the steps here. Okay. So first step, find the total resistance. That's always the first thing you do. Okay. So I'm going to call this. Actually, I'll just put some labels on here. I'll call this is V1 and this one V2, and I'll call it R1 and R2. So the first thing we do is find the total resistance. So in this case, because it's just a series circuit, we can just add R1 and R2. So it's going to be 120 plus 330 is 450 if my maths is correctly. 450 ohms, okay? So that's step 1. Step 2, you then have to find the total current using Ohm's law. Now, so we're going to use current is V over R. Now you've got to be careful about which V and which R you use. Now if we're finding the total current, we need to use the total voltage and the total resistance. Okay, you can use Ohm's law at any sort of point in a circuit. We could use Ohm's law for R1, but we'd have to use the current at R1 and the voltage at R1. Or we could use we could do it with resistor 2, but we'd have to use the current at resistor 2 and the voltage at resistor 2. Or you can do the total, in which case you have to use the total voltage and the total current. So we're doing the total in this case, so we want the total voltage, which is 12 volts, divided by the total resistance, which is 450, because we just figured that out, which is 0.0267 amps. Or another way of writing that is 26.7 milliamps. I'm just going to use the millis because you better get used to seeing them. Quite often you'll see them in the electricity papers, okay? But it's better to use the just amps number for the calculation, okay? So those are the first 2 steps. Find the total resistance, then use Ohm's law to find the total current. After that, it kind of depends on the circuit, okay? You then have to use Kirchoff's rules and Ohm's law to solve for V's and I's as possible. Now, what you can do depends on the circuit, but basically you always end up with using this total current first and then seeing what you can do with it, okay? Now, if we know, so we know that the total current here is 0.0267 amps. And because we know this is a series circuit, we know that that current is going to be the same everywhere. Okay? So we could actually use that to calculate R1. So the volt V1, sorry. We could calculate V1 using Ohm's law, except remembering because it's Ohm's law, we've got to use it's R1. We've got to use I1 and R1. But I1 is the same. Okay, so it's 0.0267, and we've got to use this resistance, 120 ohms. So 0.0267 times 120 is 3.2 volts. Okay. So it's 3.2 volts there. Okay. Now, the next thing we've then got to do, so we already know the current everywhere, and we know one of the voltages. We've just got to find V2 now. Now, V2, we could do the same thing again. We could use Ohm's law and just use the other resistance, and that would tell us the voltage. But there is another way to do it. I'm going to do it a different way, just to show you, because we know there's 12 volts being input, and this is using 3.2, V2 must be the rest, okay? Remember, V total has to equal V1 plus V2, sorry, not V total, V, the supply. So that means V2 will be supply minus V1. So we're putting in 12 volts, or 12.0 minus 3.2 is 8.8 volts. So V2 is 8.8 volts. So there we go, we've got the current and we've got the two voltages in that circuit, all by just finding the total resistance, then find the total current, and then use Kirchoff's rules and Ohm's law to find the voltages and currents as you can. Okay, I'll go through another example. Okay, so this one is the same power supply and the same resistors, but this time they're connected in parallel rather than in series. So we'll go through the same process. So step one, find the total resistance. So in this case, because it's parallel, is 1 over R1 plus 1 over R2. So in this case, it's going to be 1 over 120, 1 over 330. And if you do that on the calculator, it is 0.0114. More numbers. Okay. So, but remember, that's not the total resistance. That's 1 over the total resistance. So the total resistance is 1 over that 0.0114, which was 88 ohms exactly in this case. So the second step is find the total current. Okay, so the total current is using Ohm's law, using the total voltage divided by the total resistance. So it's still 12 volts, except now the resistance is 88. Is 0.136 amps. Okay, and the third step, I'll write it over here. solve, using all the other rules, all the rules you have at your disposal: Kirchoff's current rule, Kirchoff's voltage rule, and Ohm's law. So what else can we do? So we've figured out the total current. We know that the current here is 0.136 amps. The thing is that's going to come into this junction here and it's going to split. So we don't actually know what the current through each resistor is. But what we do know, because this is a parallel circuit, we know that V1 here is going to be 12 volts because there's only one resistor in that loop. And also here, V2 is also going to be 12 volts. Now we know for each one of those, we know the voltage and the resistance. So we can find the current. So if I say here, I call this one I1 and this one here I2, we could find I1 using Ohm's law. It's going to be V1 over R1. And we know V1 is 12 volts. And we know R1 is 120, which is a nice convenient dividing. 12 divided by 120 is 0.10000 amps. So we know that one is 0.100 amps. Now, we need to find I2. Now we could do the same thing. We could do V2 over R2, but just to show you there is another way of doing it, we know that the current coming into this one, total, is 0.136, and we know I1 is 100, so we could actually find this by going the total current minus I1, because all of the current has to go somewhere. So it's going to be 0.136 minus 0.100 is 0.036 amps. So that one here is 0.036 amps. So those two examples of how you can go about solving circuits, okay? I've done a simple series one and a simple parallel one. But the steps are always the same. First step, find the total resistance. Second step, find the total current, and then solve it. Here's a couple for you to have a go at. So these have 3 resistors in them, and they are not just series and they're not just parallel. These are a combination, but the processes are still the same. Okay, so step 1, find the total resistance. Step 2, find the total current. And then step 3, solve using, I'm going to call it Kirchoff's current rule, Kirchoff's voltage rule, and Ohm's law. Okay, so those are the processes. So I want you to have a go at solving those. I'll put an image of this up in Teams so you can have a look at it, and I will also make a video that I'll put up sometime before spell 3, so you can have a look at the solution to these two as well.